Good morning, students. So we continue the topic of real numbers, and today I'm going to take up a new topic, that is fundamental theorem of arithmetic. Now the statement of this theorem is every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. It means that if you take a composite number, so what is a composite number? It is a number which has got more than two factors. So if we take a composite number, then it can be expressed as a product of prime, and this factorization is unique apart from the order in which the prime factors occur. To explain this, I take up one example. The example is 210. It is a composite number. Now this composite number can be expressed in the case number 1 as 2 into 3 into 5 into 7. Case number 2 can also be expressed as 3 into 5 into 2 into 7. In the case number 3 we can also express it as 7 into 2 into 3 into 5. So if you look at all the three cases, these prime numbers are unique and the order is different. So that is the meaning of the statement here. Can be expressed as a product of prime, and this factorization is unique apart from the order. That means whatever the orders may be, we are using the same prime numbers. We are using 2, 3, 5 and 7. Now let me take up one more example in a different manner. I take up 126 now. It is also a composite number. Now I break up it into two branches. One is a prime, another is a composite. Again I break up this number in two branches, prime, composite, and we continue it till the last step we get both the prime numbers. Now this is a unique method which is known as prime factorization tree. It is like a tree. We got different branches and they will end at the branch when we get both the prime numbers. And so we can say the prime factorization of 126 can be obtained by, if we multiply 2, 3, 3 and 7. Look at here. 2 into 3 into 3 into 7. And this is one more method by which you can do the prime factor of composite number, and it is a form of tree known as prime factorization tree. Now we go for another formula, and the formula is for two numbers, and the formula is the SCF into LCM equal to product of two numbers. That means if we take two numbers, then the product of SCF and LCM of the two numbers will be equal to the product of the two numbers. We can explain this with a suitable example. Let the first number A be 252, B 594. So if we take up the LCM of the two numbers 252 and 594, it is coming to be 8316. SCF of 252, 594 is 18. Now if you want to verify this theorem, then we have to take up the LHS and RHS separately. So let me explain the LHS first. The LHS will contain LCM into SCF. That is 8316 into 18 gives me 14986 149688. That is the LHS. If we go for the RHS, that means we multiply the two numbers direct. Again we get 149688. Now both the sides are having the same answer. It means that the product of HCF and LCM will be equal to the product of two numbers. And this is how we can verify the theorem. We will take up the LHS separately, we will take up the RHS separately, we will find out both the answers are same, and thus we have proved the theorem. Now proceeding forward, we can take up another thing, which is the LCM and HCF finding by the method of prime factorization method. And for that we are going to take up two numbers, 6 and 20. Let the 6 can be expressed as the prime factors 2 power 1 into 3 power 1. 20 can be expressed as 2 into 2 into 5, which can be written as 2 power 2 into 5 power 1. Now if you want to find out the LCM of 6 and 20, then look at the thing. It is the product of the greatest power of each prime factor involved in the number. The greatest power of each prime factor. Now that means the greatest power of 2 is 2 power 2, the greatest power of 5 is 5 power 1, and the greatest power of 3 is 3 power 1. So the LCM can be obtained by 2 power 2 into 5 power 1 into 3 power 1, that is 120. So for the LCM, the product of the greatest power of each prime factor involved in the number. This is the technique for finding LCM. Now to find the HCF, we have the formula like this. Product of the smallest power of each common factor, prime factor in the number. Each common prime factor. And for that, if you look at again the factors, we can find out that 2 is the common prime factor, and we are going to take up the smallest power of 2, that is 2 power 1, and so the HCF of 6 and 20 will be taken as 2 power 2 equal to 2. So for finding the LCM, we have the greatest power of each prime factor involved in the number. And for finding the HCF, we have the smallest power of each common prime factor in the number. So this is how we can find out the HCF of two numbers by a method known as prime factorization method. In the next class, we will take up some more topics related to this chapter, real number. So thank you for today. Have a nice day.